This lesson is on solving linear inequalities in one variable. So we have already reviewed how to solve equations. Now we're just going to solve inequalities, which will only change one little thing. The rest of it is pretty much the same as we did before. If we've got parentheses, as we do here, we're going to distribute. Watch out for that negative times the negative. It should turn it into positive. Because this is no longer a quadratic, notice x to the first is the highest degree. We will separate them by the inequality sign. So I'm going to move all of my x's to one side and numbers to the other. If you want to simplify that right side first, 2x or 4x and negative 2x gives me 2x, minus 8 and plus 2 gives me minus 6. If I subtract 2x from each side, that gives me x plus 12 is less than or equal to negative 6. If I subtract 12 from each side, I get x is less than or equal to negative 18. So that's my solution. If I'm going to graph the solution set, I would look for all of the numbers that are less than or equal to negative 18. So I would find negative 18 on my number line. I would either put a bracket or a closed circle. I believe Alex has you put the circles. The closed circle happens because of this line right here. This means that negative 18 is included, as well as any values that are smaller than negative 18, which are to the left. Now, there is that shortcut that points the direction that you should be shading, but beware that the only time that shortcut works is when our first term is our variable term. If the variable is on the opposite side, the arrow is pointing in the wrong direction. So the inequality is solved. I've graphed my solution, and now I have to write the solution in set builder and interval notation. In set builder notation, I would say all of the x's such that x is less than or equal to negative 18. In interval notation, I'm saying the least value is negative infinity because it goes on forever to the left. The greatest value is negative 18, and 18 is included, and the included uses the closed bracket. Let's try another. Again, this one a little bit easier. I'm going to distribute the 2, so 2x minus 18 is greater than 3x plus 7. Let's go ahead and subtract 3x from each side, and then add 18 to each side. And then notice that I have a negative x, which means I have to divide by a negative 1. Dividing by a negative 1 does flip my inequality around. So x is less than 25. So a lot of people get confused by that. So let's take a look at what would happen if on this step instead I subtracted 2x instead of 3x. So let's show that real quick so you understand why we had to flip that inequality around. If I subtract the 2x, that gives me negative 18 is greater than x plus 7. I would subtract the 7, which gives me negative 25 is greater than or equal to x. And, notice that my x is on the wrong side. So if I wanted to write the x on this side, notice that the inequality is pointing at the x. So that is what my solution would look like, which is what happened when I flipped that inequality around. So whenever I multiply or divide by a negative, as I did here, 25 divided by negative 1 gave me my negative 25. That is my solution, is that I had to flip that around because I divided by a negative. Now, if I'm graphing this, again, I'm going to find negative 25. In this case, I'm going to say that negative 25 is not included. It's all of the values very near to negative 25, but not quite. So in a graph, we do an open circle instead of closed because there's no or equal to. I'm still looking for values to the left, so that would be my graph. My solution in set builder notation would be all of the x's such that x is less than negative 25. And in interval notation, it goes from negative infinity to negative 25. Remember that negative 25 is not included, so I used a parenthesis rather than a closed bracket on that example. For this inequality, we are going to use a clearing fractions technique. So I'm looking at the 1/2, the 1/3, the x, and the 1/4. So x, of course, has a denominator of 1. Looking at 2, 3, and 4, my least common denominator would be 12. So I'm going to take every value times 12. And when I do that, it's going to clear the fractions so that I no longer have to deal with those pesky fractions. So 12 times 1 divided by 2 gives me 6x. 12 times 1 divided by 3 gives me 4. Notice this x minus 2 is going to stay exactly how it was because it's going to be affected by the 12 once I distribute. So I could have distributed the 1/3 and then taken both values by 12. Instead, I took the 12 times the 1/3, and now I'll be distributing a different number. 12 times x divided by 1 is just 12x. And 1 times 12 divided by 4 is 3. Keep in mind that was a minus, so it will stay a minus. On my next step now, I'm going to distribute that 4. So that gives me 4 times x, which is 4x, and 4 times minus 2, which is minus 8. Before I add or subtract anything from each side, I'm of course going to combine the like terms on the left side. And now I can choose to move the x's to either side. I'm going to move them to the left, so I'm going to subtract 12x from each side. That gives me negative 2x minus 8 is less than negative 3. By subtracting that 12x, I'm going to add 8 to each side, which gives me negative 2x is less than 5. And now I'm going to divide by a negative 2. And when I divide by a negative, my inequality flips around. So I'm going to get x is greater than negative 5/2. So that's going to be my solution, is x is greater than negative 5/2. To graph that solution set, negative 5/2 is between negative 2 and negative 3 because it's negative 2.5. It's an open circle. And then, of course, I'm shading all the values that are greater than that, which are to the right. So that is the graph of my solution. Then I'm going to write it in set builder and interval notation. Of course, set builder is just all of the x's such that x is greater than negative 5/2. And interval notation, it would be from negative 5/2, not included, so open circle, up to infinity. So that would be my solution. Looking at our next question, again, I'm going to do some distributive property. On the right side, I'll combine like terms. Again, I'm going to get all of my variables to one side, and we notice, just as in our last question, all of my variables actually go away, and I'm left with 36 is less than 24. Unlike the last question, this is a false statement. 36 is not less than 24, which means there is no solution. If I were to graph that, it would look like an empty graph, so it doesn't matter if you had numbers on there, nothing would be shaded in. If I were writing the solution in interval notation or set builder, basically it's just empty set. No solutions. One more for us to try together. I'll distribute the negative 2. Combining negative 4 and negative 2 gives me negative 6. Adding 2x to each side will make those two go away, which gives me negative 6 is greater than or equal to negative 10. Again, this is true, so that's the all real numbers, negative infinity to positive infinity, etc. One for you to try on your own, so try this question, then press play to check your work. For this question, again, I'm going to clear fractions by multiplying everything by 8. So x times 8 is 8x. This fraction times 8 would reduce and give me 2 times 2x plus 1, because the 8 and the 4 would reduce to 2 and 1. And multiplying this fraction times 8 would give me 4 times x. Then I'm going to simplify. On the right side, I now have 8 x's. On the left side, I already had 8 x's. By subtracting 8x from each side, I get 0 is less than 2. 0, in fact, is less than 2, so this is all real numbers, negative infinity to positive infinity, etc.